Right, welcome back to my class again today. In today's class, we're learning how to call KCL and KVL for those doing engineering courses in the university and what applied and pure physics. If you are doing mechanical engineering, electrical engineering, chemical engineering, any engineering whatsoever, you are doing applied physics, this particular course on the board here, you will see it often and often. We'll call it network analysis. So in today's episode, we're looking at how to call KCL and KVL. How do you analyze KCL and what? KVL. What is KCL? KCL means Kirchhoff current law. Where KVL means what? Kirchhoff voltage law. Let's apply KCL and KVL on the board here in this what? Complex what? Circuit. However, Ohm's law has its own what? Ideas here, but KCL and KVL can do this what? Properly. Let's get the rightful what? Equations that are needed in this what? Circuit. Look at the board very well. You will notice that want to calculate the current that flows in this circuit. So in today's class, I'm showing you how to get the equations actually. Now we have I1 in this direction, we have I2 in direction, we have I3. They all flow from I1, then split into what? I2 and I3, and they will now recycle back again to what? Like that. So we have two cells here, we have V1 and what? V2, that is what? EMF or what? Potential what? Difference. It's also what? Correct. Now we have the resistors here, we have R1, R2 and R3 and the what? Resistor. How do we apply KCL and KVL in this circuit? Look at the board, please. This point C here and this point D here is called a node. A node is the point where current enters and what leaves simultaneously. So in this case, this current I1 enters this node and split into two parts, into what? I2 and what? I3. So that ideology is called KCL. KCL is the sum total of the current that enters a node and leaves the node simultaneously. So let's go. So from KCL, let's look at the board. And this point here, this node here, the junction here. So the KCL here, KCL, understand? This means Kirchhoff current law. It means Kirchhoff what? Current law, KCL. So in this point, KCL what? Is the sum total of current that enters a node and leaves the node actually. So in this case, the KCL here is what? I1 is equals to what? I2 plus what? I3 based on their what? Directions. I1 flows like this, and this junction here, or this node here, or this point here, is split into two, I2 and I3. See that now? So this is what the KCL, first equation. Now, second, at the KVL. The KVL is actually what? Kirchhoff voltage law. Kirchhoff voltage law. Voltage law, very expedient. So the KVL here is very simple. What's KVL? KVL is about this. This is KVL. KVL is talking about the summation of the voltage minus what? The drop in potential. That is what KVL. So let's now apply it here now. So it means that for the first loop, we have two loops here. We have this A, C, D, B, and A. So that now this first loop here, we have two loops. We have loop 1 and we have loop 2. So the KVL for this particular first loop, for the first loop, A, C, D, B, and A will be this. Look at the board, please. So we have loop, A, C, D, B, and what? A. It means the current flows like this only and cut across the resistors and the like on the source of the voltage here. So let's see. So we'll be having for the first loop here, we'll be having this one, V1. See that now? Because it's flowing like this, the what? Minus what? I1, R1, then come to this side, the same thing again, minus what? I2, or I3, rather, I3, and what? R3, see that now? Is equals to what? 0. That's the first thing you have to know for the first loop. Very simple. Now the second loop, loop what? C, let me say, okay, loop C, E, F, D, C, loop what? C, E, F, D, C. This loop, like this, if you observe, this particular what? Arrow is flowing in accordance with the what? Voltage, but this is what? Opposing it. See that now? So we'll be having, for this one, V2 minus, this one is normal, minus I2, R2, then plus. Why? Because it's what? Opposing it, we want plus what? I3, and what? Sorry, R3 equals to what? 0. So this is how we get the equations using what? KCL and KVL in a given circuit like this, and we have to find the word current. When I start to solve question properly, to solve for what? I1, I2, and I3, we now use numbers to what? To showcase this and to not look more easier. Understand? Very simple. Can you what? Like, share, and do a follow if it's very useful to you? My name is Carlos, and my job here is to boost confidence and drive minds. So, bye-bye.